So President Garfield, among other things, besides being President of the United States, was a mathematician, and he was credited with finding a unique proof of the Pythagorean Theorem, and he did it as follows. So notice on the board we have three triangles, triangle X, triangle Y, and triangle Z. Let's take a closer look at triangle X. I have a 90-degree angle, sides A and B, and then angles circle and star. Okay, now since it's a right triangle, circle plus star is 90 degrees. Okay, because remember, triangle is 180 degrees. Well, if we have a right angle, the other two angles must add up to 90. Let's go to triangle Y. Now, triangle Y is simply triangle X rotated 90 degrees counterclockwise. So, like, take a look at side A in triangle X. It's on the bottom in triangle Y. Side B in triangle X is on the right side of triangle Y. So, now let's take a look at the final triangle, triangle Z. Now, triangle Z was formed by just connecting the side, just connecting from here to there. That's all he did. That's how I came up with triangle Z. Notice that triangle Z is made up of sides C and C. Okay? And the question is, what is this angle here? What is that angle? Well, most of you might have guessed it's 90 degrees. Let's double check to see if it is. Well, if we add up star plus the unknown angle plus the circle angle, well, it forms a semicircle, right? Which is always equal to 180 degrees. Like I said before, star and circle adds up to 90 degrees. Therefore, this remainder must be 90 degrees, okay? Because star and circle makes 90, this makes up the other 90, which gives us the 180 that we need. So that missing angle is 90 degrees. Now let's go ahead and backtrack. So we have a 90-degree triangle, or a right triangle. Let's backtrack. So again, the Pythagorean Theorem, you know, the sum of the legs squared is equal to the hypotenuse squared, aka a squared plus b squared equals c squared. So squared usually means area. So that's what we're going to do. Find the area of triangle X, find the area of triangle Y, and find the area of triangle Z. Well, that's very easy because how do you find the area of a triangle? Base times height divided by 2, or half base times height. So triangle A is just, triangle X, the area of triangle X is half times A times B. The area of triangle Y is A times B again, base times height, times a half. And then triangle Z is C times C, aka C squared, times a half. Okay? Now let's add up all the areas. So you can see what is the area of this figure. So 1/2 AB plus 1/2 AB, 1/2 C squared is 2/2 AB, or 2AB over 2, plus C squared over 2. Now let's write this as one fraction. 2AB plus C squared all over 2. Okay, so that's what we have there. All right, let's continue. So far, President Garfield has found an expression to represent the area of this figure. Now, if we look at the figure closer, you'll realize that it's actually a trapezoid. Trapezoid, you know, has two bases that are parallel, that's connected by a height. Then we can find the area of this figure using the formula for the trapezoid, which I wrote on the top left for you, which is, again, A plus B represents the parallel bases, multiplied by the height, and then multiply by half. So let's see how this works out. So let's find the area of this figure using the area of the trapezoid formula. So if you realize the area of the, I'll write it down, half A plus B, which is the parallel bases, times the height, which is again A plus B. Okay, so these are the parallel bases I'm talking about, and this is the height that connects them. Okay, now we just have to do some algebra. This is what Garfield was doing. Everybody knows A plus B times A plus B is A squared plus 2AB plus B squared. And then we still got that pesky 1/2 in front. So we just divided by 2. So now we have a different expression that finds the same area. Okay, so That's the first area expression that we found. And this is the second area expression that we found. Okay, well, since these area expressions are equal, okay, since they represent the same figure, they're equal to each other. So finally, President Garfield just sets them equal to one another. And then you just complete the algebra, multiply 2 both sides, okay, and you're left with 2ab plus c squared equals a squared plus 2ab plus b squared. That's it. And now, what do you notice cancels out? The 2ab's go away, and we are left with a squared plus b squared equals c squared. And that's the root Garfield did. And he will probably be more remembered for finding the area, or finding the Pythagorean theorem, a proof of it, than his presidency.